Okay, so suppose you have a polynomial that looks like this. Okay, so any old polynomial, any function. Now, suppose there is a number which is a 0 of this polynomial. So let's call that number c, right? Suppose c is a 0 of p of x. We know what 0 means, right? That's where it crosses the x-axis. Okay, if you say that c is a 0 of p of x, you can also say that also means that c is a root or a solution, all right, of p of x. Now, here's the biggie. If a number is a 0, then x minus the number is a factor. So suppose you have a function, f of x is equal to x squared plus 2x plus 4. Okay? So that's a function. Now, x equals 2 is a solution of that. X equals 2 is a 0 of that. Okay? Now, if x equals 2 is a 0, that implies that x minus 2 is a factor. Right? So if x equals 2 is a 0, then x minus 2 is a factor. Okay? And then, so that number is also an x-intercept. All right. So let's take a look at this function here. Look at this function. What are the zeros of this function? Here, this graph here. What are the zeros, Sydney?
-3, -2.
Uh-huh.
1, positive 1.
Exactly. So -3, -2, 1, and 2 are all zeros of this function. So guess what? X minus -3, which is x plus 3, is a factor. X plus 2 is a factor. What other factors are there? So x plus 3 is a factor. X plus 2 is a factor. What other factors does this have? But what? X minus 1 and x minus 2. So all of these are factors. Right? So if a number is a 0, x minus that number is a factor. Okay? All right. So here we're going to start by, factoring again. We're going to solve these by factoring, and then we're going to state the number and type of roots. Okay. So let's factor this guy. How do we factor this? It's going to be x, two numbers. 8 and what? 8 and -6. Good. Right? So those are the two factors. X plus 8 is a factor. So x equals -8 is a 0. And x equals +6 is a 0. So those are the zeros. Those are the solutions. It has two real zeros. Okay? Now, what about this one? It says to solve by factoring. And I know you could take the 256 to the other side and take a root, blah, blah, blah. But if it says by factoring, we have to do it by factoring. All right. Perfect square, perfect square. So I can factor this way. X squared. What's the square root of 256? 16. Good. 16 plus minus. Can I factor the first one anymore? No, but the second one I can, right? So here, x minus 4, x plus 4. Okay. Because it's a plus inside. Okay, if it's a perfect square, if it's squares, but plus inside, you can't factor. Yes, Max?
Why is it 2
Because you have two solutions and they're real numbers, not imaginary. Okay. Yes.
When you're writing the answer, so you write like x equals 4,
Yes. Yeah. Okay, so from here, we're going to get x equals 4. We're going to get x equals negative 4. But what about here? What do we do here? Yeah, so this one, we're going to set it equal to 0. X squared equals negative 16. Take a square root of both sides. What's x then? Just 4i plus or minus 4i. So now, if you want to write the answers then, you can say x equals plus or minus 4 and plus or minus 4i. Okay? So, how many types, and what's the type of solutions here? One real or two real? Two real, two imaginary. Okay, so now look, this is x to the power of 4. Degree 4 means 4 solutions have to show up. Real and imaginary together, you've got to end up with 4. Not 1, not 2, not 3, 4. Not 5 either, 4. This is math exact. So 1, 2, 3, 4. Okay? All right. How can we factor this? What do we do first?
Take out the x.
Good, and I have x to the 4 minus 8x squared plus 16. All right, here. Is 16 a perfect square?
Yeah.
Is x to the 4 a perfect square?
Yeah.
What's the square root of 16? Okay, is that 2 times 4? It's right. So, I can factor this like this. It's a perfect square trinomial. So it's x squared 4 minus here means minus there. Okay? Now, how can I factor that further? This is x times x minus 2 x plus 2 squared, okay, equals 0. Okay, what are the zeros here? X equals, from here, what do I get? 0. From here, plus or minus 2. So how many is that? How many do I need? What's the degree? 5. Where are the missing 2? They're not imaginary because we solved them all. There you go. Look at this. This whole thing is squared, right? So when I write that out, let me write that out. It's x times. This inside is squared. So technically I have x minus 2, x minus 2, x plus 2, x plus 2 equals 0, right? So look, from here I get x equals 0, x equals 2 twice, right? I only write it once. We call that a repeating 0, okay? This is a repeating 0. And then here, x equals negative 2, repeating 0.
You have to write repeating.
So we're going to revisit it later. You can either say a repeating 0 or multiplicity of 2. Now, at this point in Algebra 2, I'm not going to require us that we write that, but I do want you to always, always, always keep count that you're getting the correct number of zeros. So 2 here, it's a repeating 0 or a double root, or it's got a multiplicity of 2. So 2, 4, 5. It's fine if you just say x equals 0 and plus or minus 2. And it's got 3. Okay, so x equals 0 plus or minus 2. And it's 3 real with 2 repeating. But basically, always, always, always keep count Because you know what? Take a moment here to appreciate the consistency of math. We want 5 solutions. You will always get 5 solutions. They might be imaginary, they might be repeating, but you're always going to get 5. You see that? Like it's almost magical how cool that is, right? So like appreciate the beauty in that. Okay. Fundamental theorem of algebra. My goodness, how important do you think that is? It says every polynomial has at least one root, right? So basically you can never say, oh, this polynomial has no solutions. No, no, no. Every polynomial has at least one solution. It could be real, it could be imaginary, but it's got a solution, okay? Now, from that, you guys remember the word corollary? What was a corollary? You guys remember? In geometry, you have theorems, and then something that like you can figure out from a theorem is a corollary. But basically, the corollary says what we've all been doing. If a polynomial has degree n, then it has exactly n roots. If the degree is 5, it's got to have 5 roots, period. Okay? All right. Now, Descartes' rule of signs. Okay, have you guys heard the phrase, I think, therefore I am?
Yes.
Okay, Descartes was a French philosopher and mathematician. He's the one who said that first. Okay, so Descartes has a process that tells us exactly what type of roots a function will have. Okay, so I know this has 5 roots, right? Okay, so it could be 5 real, it could be 5 negative, it could be 3 negative and 2 positive, it could be 4 imaginary and 1 real. Descartes, when we use his rule, we can come up with a chart and we can predict the number and type of solution. So we can predict this stuff, okay? All right, so let's do this. Okay. I'm missing some x's, parentheses here. Why? Oh my. Okay. All right, so this in the box explains the process of what we're going to do. But here, in example 2, I've described what it says in this box here with steps. So let's figure out, so let's just go through that, okay? All right. So what we're going to do here is we're going to find the possible number of positive, negative, and imaginary roots, all right? And we're going to create a table. So this is our polynomial here. So what we're going to do is this. Okay, you take p of x, and you want to examine the sign changes of p of x. Basically, you go down this polynomial, and you look at the coefficients, and you want to know how many times the coefficients alternate between negative and positive. Right, so the first term here, what's the coefficient? Negative 1, then positive 4. So here you have one time where the sign changes, and then another time where the sign changes here. Okay? So that's twice. Okay? So this tells you that okay, how many total roots does this function have? 6. Because the sign changes twice, that says of the 6, you're allowed to have a maximum of 2 positive roots. Okay? Now, Descartes' rule says when you find that number, subtract 2. You always subtract 2. Why subtract 2? We'll ask Descartes one day when we run into him in the afterlife. But for now, we're just going to keep subtracting 2. So you subtract 2, what do you get? 0. So 2 or 0 positive roots. Okay, now for the negative ones. Now what we need to do is find p of negative x. Okay, how do you find p of negative x? Basically, in this polynomial, for each and every single x, we're going to substitute negative x. So it's going to be negative x to the 6 plus 4 times negative x to the 3 minus 2 times negative x squared. Oh no. Negative x. Okay, you're not going to believe this.